Okay, here I think is the last page of questions from your assignment. It says here to factor 4c squared minus 49. 4c squared minus 49. This is a perfect square. That's a perfect square. This is an a squared minus b squared thing. And those always, that's a bracket, work out like this. That's just a shape we have to memorize. So what are the a's? So 4c squared breaks down to 2c times 2c. 49 breaks down into 7 and 7. So it's just 2c plus 7, 2c minus 7. So 2c plus 7, 2c minus 7, that's right here. And we'll just double check. 2c plus 7, 2c minus 7. 2c times 2c is 4c squared. 2c times negative 7 is negative, 14c. 2c times positive 7 is positive 14c. And 7 times negative 7 is negative 49. So we end up with 4c squared. These two are our like terms. Negative 14 and positive 14c cancel each other out. And negative 49. That's what we started with. We're okay. Next, how many of the following statements are true? Let's look. 1 over a plus 7 is a polynomial. No. It can't be a polynomial because we have a variable on the bottom. That one's no good. Next, which also means that it can't be 3. The degree of a polynomial is the degree of the term with the highest degree. For degree of a polynomial, we're looking for not just that term that has the highest degree. We're looking for the degree overall. What else do we have here? Oh, no, but all in the term, in that whole term. Yeah, okay. So if we had like 7x squared, the degree is 2. But if we have 7x squared y, the degree is 3. If we have 7x squared y cubed z, the degree is 2 plus 3 plus 1. The degree is 5, 6. But if we had another one like here, plus 2c plus 7z squared, we don't add these ones in, just in that term. Okay, just in that term. This one looks right. Next, like terms are terms with the same variables raised to the same exponents. So if we have like 7x plus 7x, those are like terms, or plus 1x, or plus, I don't know, pi x, whatever. Same variable, same exponent. So if it was 7x cubed plus x cubed, those are still like terms. If this was an a instead, these would not be like terms. If this was a squared instead, these would not be like terms. So same variable, same exponent. That sounds right too. 2 of these are good. Next, which of the following pairs of integers has a product of negative 55 and a sum of negative 6? So we're looking for factors of 55 that have a difference of negative 6. So negative 55 could be 1 times 55. Remember, one of these will be positive, one of these will be negative. Negative 55 will be, well, 5 times 11. I think that's it. So we're looking for a sum of negative 6. So we need the bigger one to be negative and the smaller one to be positive. So negative 11 times positive 5 gets negative 55. That's the product. And the sum of negative 11 plus 5 is negative 6. So positive 5, negative 11. That looks like this one here. And again, this question just boils down to add these together and see if you get negative 6. I don't like that question. That seems way too easy. Here, how many of the following statements are true? Root 3 plus x squared is a binomial. Could be. Roots are okay as if they're not containing the variable. What else do we have? negative 6x plus 5x to the negative 2. That one cannot be a polynomial because, well, that x to the negative 2. X to the negative 2, this bit right here, is not allowed. So this statement, false. The constant value of a half plus a squared is 1/2. Yep, that's the number, all right. Sure. Next, the degree of this binomial, negative 3xy squared plus 9xy cubed, is 7. So the degree of that should be, if we take the sum of all the exponents in the biggest term, the term with the most stuff in it. So if we have x, which is to the 1, and y squared, so that degree of that term is 3. The degree here is 3. 1 plus 2 is 3. And if we take our second one, 1 plus 3 is 4. So the degree of this one should be 4. No good. And next, oops. A monomial is a number or a variable, or the product of numbers and variables, which is a lot of writing to say that it could be a letter or a number together with a letter, which it can be. It can be any of those things. So, yeah, that's true. So this one was true, this one was true, this one was true. 3 of them were true. I think that's the last question on this assignment. Post these up soon.